Okay, a bit more then on our ASFurther maths. We're in the middle of complex numbers, so condition for two complex numbers to be equal. I'm not going to spend too long on this little bit here, but effectively if two complex numbers are equal, if you look all the way down here, then the a bits, so their real bits, must be equal, and their imaginary bits must be equal. That should be a b there, actually, that's a slight misprint. And that has lots of applications for us and to kind of help us work out other bits and pieces. One of the examples then will be below, so let's take a wee look. So you're asked to find the square root of 15 plus 8i. So one of the square roots is going to be a plus ib, and we need to work out the a plus ib, and that is equal to 15 plus 8i. If we square both sides, we get a plus ib all squared equals 15 plus 8i. Multiplying this out using FOIL, we'll get a squared plus 2abi minus b squared, remember, because we're doing b times the b, which gives the b squared. The I times the I is going to give us a minus 1, and that equals 15 plus 8i. If we separate this out into its real and imaginary bits, we're going to get a squared minus b squared is the real bit, because there's no I in that bit, plus 2abi equals 15 plus 8i. And then this is one of our applications then of what we have above. If that's the case, then a squared minus b squared must equal 15, and 2ab must equal 8. We call that equation 1. We call that equation 2. Rearranging equation 2, we can have a equals 4 over b, and we're going to sub that in. It's effectively two equations, two unknowns. This is a slightly more complicated version of it, and we're going to sub that. So we're going to exchange our a here for a 4 over b. So we will have then, let me see, what way have we got this written out? So we're going to have 4 over b all squared, take away b squared equals 15. Tidying that, then we're going to get 16 over b squared minus b squared equals 15. And then we'll bring this up to the top and start working down the other side. Hopefully you're okay with that. Our way to solve something like this is we're going to multiply through by b squared. So if we multiply through by b squared here, we're going to get 16, take away b to the power of 4 equals 15 b squared. If I rearrange that and take everything over to the one side, I'm going to get b to the power of 4 plus 15 b squared minus 16 equals 0. Factorizing this is a bit weird. We haven't solved one of these before, but we can just effectively take our b squared as our normal term if it was a normal quadratic. So we would have then b squared plus 16 and then b squared minus 1. That's going to give us, that is right, isn't it? Yeah. That's saying going to give us b squared equals minus 16. I know we're in the world of complex numbers, but this b needs to be a real number. So we're going. This is going to give us no solutions. You can't take the square root of a minus if b is going to be a real number, or we're going to have b squared equals 1. So that gives us a value of then b equals 1, or b equals minus 1. Subbing it back in then to get our values for a, we know that a is 4 over b. So in this case, 4 over 1 is going to give us 4. 4 over minus 1 is going to give us minus 4. So the two square roots then of 15 plus 8i are going to be 4 plus I, or minus 4 minus I. And sure enough, if you square this, you will of course get 15 plus 8I, and if you square this, you'll get 15 plus 8I as well. So those are two possible answers then for that. Let's take a wee look at the next example. Reasonably straightforward one. Find the real numbers x and y if 3x minus 2y plus 3i equals 4 plus x plus yi. Again, if these two complex numbers are equal to each other, then we can just equate the real and our imaginary parts. So I'm just going to write that wee sentence. Equate real and imaginary parts. So the real parts of this one are 3x minus 2y. The real parts of this one are 4. I'm going to call that equation 1. The imaginary parts of this one are 3. The imaginary parts of this one then are x plus y. I'm going to call that equation 2. Whatever way you want to do this, I don't mind. I could rearrange 2, I suppose. X equals y. No. 3, take away y, and then sub it in there. So you have 3 upon 3 minus y minus 2y is 4. 9 minus 3y minus 2y is 4, and that gives me a value then of y equals 1. If x plus y is 3, then x equals 2.